based on this diagram, which is the Hive architecture, inside the Hadoop component, you have a Hive. Okay? You have a command line interface. You all know what is the use of a command line interface. So what this interface is about? What is the use of an interface? Is to communicate with the hardware and the software and with the OS. Okay? So your command line interface is to communicate within a three-way communication between your hardware, software and the OS. Okay? So that is what is here. Then you have a Hive web interface to communicate with the online. Okay? When there is an online repository or when there is a web service to get communicated, you have to have a Hive web interface. Here, we have a driver class. So you have a drivers, which is nothing but your compilers and executors. So what is the use of a drivers? Where do you have drivers? PC and also you said it is a software. So software in your Java virtual machines, your Java programs, right? So that is what is here to be your driver. So that is what is here, your driver, which is having your compilers, extractors, everything. Then you have a meta store, very important terminology here to look into what is meant to be a meta store. We'll see what is a meta store, and you all know what is a job tracker and a task tracker. So job tracker and a task tracker are your map reducing phases. Okay? So your Hive has the HDFS as well as your map reduce phases. Okay? It has the HDFS, also your map reduces spaces, which is inside your Hadoop cluster. So this is what is your architecture is about. Your architecture will have the Hadoop distributed file system, which is the bottom line of your structure, followed by the map reducing program. Then you have a huge component building, like you have a command line interface, you have a web interface, then you have a Hive server, then you have a meta store. So this is how your architecture is about. So what is the use of your meta store? We'll see what is, and what is the use of your JDBC ODBC? What is JDBC ODBC? Java database connectivity. ODBC, other distributed database connectivity. Other distributed database connectivity could be anything. Okay, it could be any of the query language that is supported by the Java. So that is what is the connectivity between your backend and your frontend, which could be able to communicate here. So this is what is this diagram. We'll see one by one here. Line interface to interact with the Hive. Okay, since your Hive component is built on a Hadoop cluster, you need that component to be communicated with an interface. That is why you have a CMD, you have an interface. Then web interface, what is the use of a web interface? It's a graphical user interface to interact with your Hive. Okay? What is the difference between a graphical and a non-graphical one? Why that is being here is mentioned as a graphical one. Front-end device we go through with, that is what is the meaning here, graphical interface. And you have a JDBC, ODBC, Java code can be written to connect with the Hive and submit jobs on it. Okay? Where you are connecting your database of the Hive to a Java, and it can be connected to the other backend for the database through ODBC. Okay? So that is what is the understanding. And you have a driver here. Driver, it compiles, optimizes and executes all your Hive queries. So that is what is here. And meta store. What is a meta store is? It is having all your DDLs, that is table definitions and mappings of the data. So all your, whatever the content that is being stored in the table will be there in your meta store. Like your metadata, here they call it as a meta store. Okay, so that is what is the simple understanding here. So meta store is nothing but table definition and mappings to our data that are stored in the database. Then it can directly communicate to an interface in the Hive. So that is what is the understanding here. Metastore service offers interface to the Hive. Then the database, you all know, database will store the content of the data which you wanted to process, and it can be given in the taken from the Hive cluster. Okay, so it's a Hive is a component. It's a query, it's a database store where the process data can be stored here. From that, you can take it, the huge number of data which is being processed. Okay, so that is what is the simple understanding of the Hive architecture. So talking about your metastore, you have 3 different types of metastore. Take down the definition of a Hive metastore. So what is a Hive metastore? So Hive metastore is a database that stores metadata. Very, very important terminology. It stores the metadata about your Hive table. Okay, which is a table of column, location, storage, everything is about. Where it can have partitions, it can have a storage of the tables, and it can have buckets in the table. That is a group of data which is being stored in the table. All the information regarding this particular data will be stored in the metastore. So it is a database which is having the information about your data in the form of table. Okay, so that is what is the simple understanding here. When you create a table, the metastore gets updated. The metastore gets updated with the information related to the new table from the old one. Okay. நமக்கு ஒரு புது டேபிள் கிரியேட் பண்ணணும் அப்படின்னா what you have to do, you have to take the information from the old one. So that is what is the, so metastore gives all your stored table information. So that is what is about. Where your metadata, you take the data about data. Likewise in the metastore, you take the information of the data which is stored in the form of table that can be taken to another table. Okay, so that is the understanding here. So all your information is stored in the form of table, which can have the location, name, type, everything here. Okay. So now it contains ID of the database, tables and indexes. So each table will have a specific ID and it will have indexes of the particular table which is stored in your metastore. Okay? So that is why the reference can be made easily. With the indexes from the old table to a new table, which could be made very easy through the indexes of the table. So that is the understanding here. So which is your table creation time, your input output format, everything will be updated in the metastore. So that is what is here. You have 3 kinds of metastores. So what are the 3 kinds of metastores? Embedded metastore, local metastore and remote metastore. Okay? You have a metastore which is in the Hive of 3 different types, which is embedded, which is local and which is remote. Embedded, by the name itself you can able to understand what is meant to be an embedded one. What is a embedded? main Hive server run embedded, which is built in that particular. So that is what is here the embedded is about. Where a local metastore, so wherever the server is being taken into consideration, that machine can be considered as a local metastore. Okay? So Hive metastore services runs in the same process as the main Hive process, but the metastore database runs in a separate process and can be a separate host. So that is what is through a JDBC connectivity. You take that. That is a local metastore. Then you have a remote metastore. By the name, since you can understand, it could be somewhere else. Okay. So within the machine intake is the embedded one, and you have a separate, in a local machine itself you have a separate metastore and processing differently, and you have a somewhere else the metastore store. That is your remote. Okay. So these are the 3 different types of metastores, which is nothing but the information of the database, which is stored in the stable structure, which is having a column, name, ID, location in the bucket of data. Okay, which could be of any 3 different types. Okay, so this is the simple understanding about your metastore. Okay, so then Hive and Hadoop is getting into the workflow. So by the diagram, you can understand here, you have a series of steps here, 1 to 10 in your Hive, as well as your Hadoop having the different component there. So you know about your Hadoop, we have only the job tracker and the task tracker, and the cluster has a name node and a data node. Mainly your Hadoop will have only these components, right? Whereas telling about your Hive components, see here, you have an interface. You have an interface which is a command line interface, which is a 1, which is connected to a driver, and from the driver it could be taken into the consideration, can be a compiler or an executor or anything, which is taken to a metastore of the database, which is stored for the data which is stored in the column structure, the table structure, and also like it could be taken to back for the compilation process after it is freed from the database, and from that it is being taken to execution engine, and from the execution engine it could be taken back. Okay, so that is what is here. It could be for the MapReduce process, for the job tracking and your task tracking, which is the map phase and the daemon phase by the Hadoop cluster. That is, the simple understanding is all the storage process will be taken place by the Hadoop, and all your processing phase, which is apart from your MapReduce, will be taken place by your Hive. Okay, you are replacing the database which is stored in the Hadoop by processing the database in the Hive. So that is the understanding. Okay, so Hadoop process பண்ணாம இன்னொரு காம்பனன்ட் வச்சு MapReduce பண்ற ஜாப் வந்து டேட்டாபேஸ்ல ஸ்டோர் பண்றதுக்காக யூஸ் பண்ற காம்பனன்ட் தான் Hive. So that is what is this connection is about. So this connection will tell you how your workflow between your Hive and Hadoop take place. So at last comes your execution engine. So first is your interface, next is your driver, next is your compiler, next is your metastore, then comes your map process, which is nothing but your job tracker, then your task tracker, then comes your name node and data node, which is nothing but your HDFS files, then back to your execution engine. Okay, the processed data will be stored back again in the execution engine, which is nothing but your database. So we'll see Hive database. data, complex data. Here you have numeric data types separately, your string data separately, and you have a miscellaneous types separately. Mainly, you have all your numeric data types, which can be a whole number or a float number, where it can be a 8-byte or more than that. Then you have a string type. Based on the version, the types could vary. We know that Hive 0.10 was the initial version, then it was moved on to 2, then it was moved on to 3. So that is what here your string variable pair all. You all know all these basic, and miscellaneous comes under your Boolean and binary. So like you have a special here called as a binary, only available starting with Hive. So you will have all these data types which is included in your query. When you are using your query, you will use all these types of data inside that, right? To define your variable inside the query, you are using that. The collection data types also in Hive: struct, map, and array. You have a collection data type in array, which is struct, map, and array. Struct is used similar to your C struct. What is the difference between a struct and a union? You are taking the highest point in the memory and you are allocating only so much, right? The remaining portion will be wasted, right? Whereas in that you will not get wasted. That is also very important to consider when in terms of the difference. So that is what you have to know about. In terms of your here, the similar way your struct, your map, your array, which is being used here. So your text file format, very very important. Note when you Hive, you will have a text file. Default will be your text file format. Default will be your text file format. Each file will be stored in a record, which is having the field. And you all know what is the CSV and TSV formats: comma separated values and your tab separated values, or XML or a JSON. What is JSON? Java separated object notations. Okay, so that is what is here. Your XML is your extended markup language, which is a semi-structured format. Your Hive supports only a semi-structured and a structured data type. Very very important, not a unstructured one. Okay, that also you have to keep in mind. Okay, so that is what is here. The term field is used overriding the default delimiter. So the field is like, you know the difference between override and override. Another thing, have a record columnar file. You have a RC file here, column oriented manner, RC file. So you note down that alone. You have a sequential file, you have a RC file for aggregation. RC file for aggregation you all know, only you are making a particular needed data to one particular group is your aggregation. This is what is your file format is about.